All right, here we go. Today we're talking about Natural Wonders Chapter 2. It's all about mineral ores. So please make sure you have your Natural Wonders packet out and we'll get right to it. This week, before we even get to looking at any pictures for identification, there's a whole lot of information we need to talk about first. If you look at the second paragraph in your packet, you're going to see the definition of a mineral. Okay, and the definition of a mineral, it's not as easy as one sentence definition that you might see with other words, other terms in science. There's actually 5 different criteria, 5 kind of checks on a checklist that need to be satisfied for us to call a material a mineral. Okay, and look right there with me as we go through this, but number 1 is naturally occurring. Minerals have to occur out in nature. They can't be made in a test laboratory or something like that. Number 2, they have to be solid. Okay, they have to be solid at a wide range of temperatures found on Earth's surface. So has to be a solid on the coldest day in Antarctica, and it also has to be a solid on the hottest day in the middle of the desert. Okay, so has to be solid at a wide range of temperatures. Number 3, has to be inorganic, so not alive and never having been alive before. Number 4, some chemistry, has to have a definite chemical composition. And what I'm talking about with definite chemical composition, if you look at the minerals in the name, right after the name, there's a chemical formula. And that mineral, like I'm looking right at galena, PBS, okay, so it's lead and sulfur. Galena is always made out of lead and sulfur. If there's a difference in the chemical formula, it's a different mineral name. And number 5, a definite or defined crystalline pattern or crystal structure. Okay, this just means that the internal arrangement builds in a certain pattern. And it shows it on the outside. Like we'll eventually see quartz, and quartz always grows with 6 sides that come to a point at the end of the crystal. Okay? The other important thing in those paragraphs is talking about environments where minerals form. And if you look at, starting in the 3rd paragraph, it talks about a hydrothermal solution. Hydrothermal, you can break that word down, it means hot water. So we're dealing with hot water and the elements dissolved in that water. As the hot water cools, ions are going to produce bonds, and when they do that, they form minerals. Okay, that's going to be a common theme you're going to hear me say. Producing bonds, producing minerals. Looking in the next paragraph down, it talks about an igneous environment. Igneous really means molten rock made from lava, made from magma. Same idea. Magma is an element stew. So it has a whole bunch of elements in this molten magma. And as the magma cools, those elements produce bonds with one another, and they produce mineral crystals. The very last paragraph is about a sedimentary environment. Also, sometimes I refer to it as precipitation, and that's just because that's the term we use in chemistry when we form a solid from a solution. So this is just air temperature, room temperature water, and as the water evaporates, the elements are left behind. Okay, now that we have that information out of the way, we can actually start taking a look at the minerals. All right, so the very first mineral we're going to be looking at is the mineral galena. Okay, and galena, you can see the chemical formula there, it's PBS, and that stands for lead and sulfur, like I mentioned earlier. Some ways to identify galena, things you're looking for, is cubic cleavage. So you'll see a lot of 90-degree corners here. It's also metallic, and it's very metal looking. And this is the one, when we actually get our hands on these, this is the one that has a very heavy feel to it, high density. Number 2 is hematite. Hematite is the only mineral we're going to see that has a reddish brown streak. So it's really important that you see that streak plate and you see the reddish brown. It also can look metallic, it can look kind of shiny like metal, but the reddish brown streak really gives it away. You can see in the chemical formula, it's an iron ore. The 3rd mineral we're going to look at is magnetite. And just by listening to the name, magnetite, you know this mineral is magnetic. So that's why in our picture, in the video, you'll see there's a magnet sticking right to it. Also has a very dark black streak. That's going to be important to see as well. Moving from that, we go to malachite, which this mineral just looks amazing. Just the natural color of it, I think, is just beautiful. And then when it gets polished and shined up, it looks even better. But the thing you have to know about malachite is it's a copper ore. You can look at the chemical formula. The Cu stands for copper. So this is one where we get and extract copper from this mineral. The next mineral is chalcopyrite. And chalcopyrite is a gold color, and sometimes they look like big gold nuggets. It's also a copper ore, and that kind of gold color really gives it away, chalcopyrite. After chalcopyrite, we get sphalerite. And sphalerite has a yellowish brown streak. So don't get this one confused with a reddish brown like hematite. This one is a yellow brown, a much lighter brown color. From there we move on to spodumene, which also has cleavage and some flat edges. And to me it almost looks like bones. If you ever find bones out in the middle of the woods, to me it kind of has some striation, some length to it that almost looks like bones. Bornite is our next mineral, and bornite is described as being iridescent. So that means that it changes color as you move the mineral around in your hand. You can actually pick it up and roll it around just like the video it's rotating, and you can watch the colors change on the rock, almost like watching gas on the surface of water. The next one is cinnabar. And cinnabar is this really interesting kind of red color. And if you look at the chemical formula, this one is a mercury ore. And mercury is not good for people's bodies, okay? It leads to mercury poisoning and really what's called Mad Hatter disease, okay? Hatters, the people that used to make Abe Lincoln's top hat, they used to use mercury as part of the process of making the felt for the hats. And they would absorb the mercury into their bloodstream, and it would eventually collect in their head. And that led to Mad Hatter disease. But it's not like Mad Hatter from Alice in Wonderland where he's jumping on tables all over. It's actually a very reclusive change to the Hatters. They pulled away from people and society and became really reclusive. So Mad Hatter disease comes from mercury. Okay, mercury comes from cinnabar. After that, and to wrap up the chapter, is willemite. And this one, it might not look too interesting right off the bat until you kind of turn down the lights and turn on a black light. Okay, this one fluoresces, it glows that bright green with ultraviolet light, okay, a black light. And that's when this mineral really stands out from the others, and it really looks amazing. That's going to wrap up all of our minerals for chapter 2. Make sure you fill out the focus questions, and if you don't understand any of the focus questions, if you can't find the answer, please make sure you ask in class. Okay, good luck studying, and I'll see you later.